In this lecture, we'll look at the challenges we face with deploying and maintaining machine learning systems, and in the next lecture, we'll explore solutions. The goal, of course, with understanding the challenges, is to better equip us to tackle and defend against these challenges. This is a diagram from a paper called Hidden Technical Debt in Machine Learning Systems, and what should really strike you about the diagram is that the machine learning component is that small black box in the center, and that there are many other surrounding components to consider. We'll be exploring many of these components in the course, so don't worry if you're not familiar with them all right now. The sheer complexity of many machine learning systems really adds to the challenge of deployments. Solé has already talked about the importance of reproducibility in the previous section, and we have to keep reproducibility in mind as we design our system and think about architecture. One of the key challenges we'll face will be around data dependencies. Whether we're talking about data that's used directly to train our model, or raw data that represents inputs to pre-processing and feature engineering work, we have to manage it carefully. Internal data can be removed or updated without our knowledge, and external data can change suddenly. This can have implications for our model deployment and represents one of the key challenges we face. Managing configuration is another noteworthy challenge in machine learning systems because in addition to standard application config, we now have config for things like model hyperparameters and model versions, and this increases the complexity and understanding required for a system config. Data preparation and feature engineering code can be very complex and comprised of many steps in our machine learning system. We need to ensure that we deploy this code to production in a way that does not cause differences between the research environment and production. Testing is another huge challenge to consider when it comes to machine learning systems. This is because traditional software tests look for exceptions in our code, but exceptions won't be thrown by a model that is simply underperforming or returning incorrect predictions, so we need to design alternative ways of capturing and detecting those mistakes in our models. There's also the makeup of the team to consider when it comes to our machine learning pipeline deployment. Of course, we have data scientists who tend to work more in the research environment, software engineers who tend to work more on the production applications, DevOps engineers who are responsible for the system infrastructure, and product owners or the business who have the best understanding of the requirements for the system. Now, a breakdown of communication between any one of these teams can lead to a deployment underperforming or failing. Depending on the size of the company, the lines between these four departments may be blurred. You may have software engineers who are working more in the research environment or doing more DevOps, but the principle applies here that you're likely to have multiple disciplines who all need to communicate with each other to ensure an effective deployment. Here's a quick summary of some of the differences between the research and production environments, and we can see that many of the luxuries of the research environment vanish when it comes time to deploy to production. The entanglement with existing customer-facing code, the need for reproducibility, often for regulatory reasons, scaling, infrastructure planning, these are the challenges we face. So hopefully at this point I've convinced you that it's worth getting strategic about your machine learning system deployments and thinking carefully about the system architecture. In the next lectures, we'll explore options for tackling these challenges.